what you think it's generally about, and do your pre-observations, okay?
So the title is comparing the two mixtures. So you have to add everything, you compare them to see the differences of the two mixtures, substance E and substance F.
And what are you putting the substances in, or what are they being?
Test tubes, and then you put water in.
Okay, so it's how they're reacting in water.
Yes.
Okay.
So first you have to put a lab scoop of substance E. And Nick's going to measure out 10 milliliters of water.
You can cap it. I think you're done.
Just water?
That's no, it's not. Let's just leave it. It always falls.
Okay.
Do I have my
Okay,
goggles?
so
Use my goggles.
Lead. And as you can see, it turns into
Okay, measure out 10 again,
Oh,
so we can save a little time.
fine. It turns into a transparent red mixture.
You can close it up. Thank you. Okay, and we pour our water in. Is it pretty good?
Yeah, it's good, it's good.
Okay, good. Okay, so for them to see it, you're gonna have to hold it up. So one person hold up the red at the top. Make sure your hand's not near the base.
You didn't get anything.
Hold it up higher. So your hand's not in the way, because your hand is there. And kind of rotate it so you can see it. All right, who wants to talk about what happened when your substance was exposed to water? Presenters?
Okay, well, when substance F was exposed to water, you can see that at first it looks very cloudy, almost opaque, because you can't see through it. And although you can also notice that on the top there's little particles of, and the bottom, yes, of substance F still there. And if you look close enough, you can see that there's also little particles of substance F floating inside the water. So you can see that they didn't fully mix. They just the substance F just kind of went into the water and
Sunk?
sunk. Well, not only sunk, part
But
of it floated, but
Very good, okay.
it didn't mix. It's not a new substance. It's just substance F and water.
Okay, so some of it sunk, some of it is still floating at the top, and then it's cloudy in the middle, so some of it is in the middle. Some of the substances in the middle might settle, or it might stay right where it is in the middle. So last year, you can use water in a substance, and if they separate out in different levels, what do we call that? You did this last year. When you have substances that might have different densities that separate out. Well, that's one of the words we do want to talk about. But yes.
Polar?
No. This is a column. Are all the things the same density here? Are some of them at different levels?
Yes.
So what does that tell you about their densities?
That they were very close.
Well, not all of F is at the bottom. Parts of F are at the top. So you can use water to, hurry up, hold that for me, to compare the two mixtures. And what about the two mixtures?
Well, Hunter said that since they can mix, I was maybe immiscible.
Right, and that's what Allie said, right? How many of you guys heard of a density column? Remember density column from last year? So some of the parts are immiscible, or don't mix well, but then you also have some parts that actually might be different densities. So you can use water for two different reasons. You can kind of review what water can be used for if you're testing to see if you're comparing two mixtures. Look at this. Look at the red. How is this different from the red?
Color.
How is it different from the red? Yes.
White is opaque and red is kind of translucent.
Okay. Transparent. Okay.
It's not really transparent though. I mean,
Okay.
because like transparent would mean that light can get through really.
Do you think light can get through there?
Yeah, I guess, but translucent. I think translucent would be a better word.
I think sometimes we use both of them. All right, so what would you say about the substance, the red substance? We said that this is immiscible or does not mix well. What would you say about the red? Jessica?
Miscible.
Which means
It mixed really well.
it mixed really well.
Just mixed.
Okay. Thank you.